Something that can make your life much easier is recognizing that you're dealing with either an odd or even function when you integrate. Now, what's an even function? The mathematical definition of it looks like this. So let's take a concrete example of an even function. X squared. And so you could see graphically that with even functions, they're symmetric about the y-axis. You could also use the definition directly. So for example, if f of x is equal to x squared, you'll have f of negative x is equal to negative x squared. You just plug in wherever you see an x, a negative x, and you get x squared. Well, x squared is just f of x. And so you could prove that directly. So that's how they look graphically, and that's how you could use the mathematical definition. What about an odd function? Here's our mathematical definition, and an example of an odd function is, for example, x cubed. Okay? If we let that be g of x, you could see that g of negative x is equal to, wherever you see an x, just plug in negative x cubed is equal to negative x cubed, like that, is equal to negative g of x. Okay, so we proved that x cubed is odd mathematically as well as pictorially, where here graphically you could see that with odd functions they're symmetric about the origin. So you flip it around y and then you flip it around x. Okay? And how could our life be easier with integrating even and odd functions? This theorem should help. So with an even function, and it's very important that we're integrating over symmetric intervals here from minus a to a, where a is a positive real number. Okay, that's important. So for even functions, this is how that would look around the symmetric interval. And you could see that this area here is exactly the same as that area on the right. So why do that integral from minus a to a? Instead, just multiply the area on the right by 2. Okay, and that could help us. For odd, if you take a look at here, this is an odd function, you could see that area there has the same magnitude as this area there, but opposite signs. The net area here is negative, and the area here is positive. And so when you do this integral from minus a to a, this area will cancel that area, okay? And you get 0. Now that could make our lives much easier. Let's look at an example. So here we want to integrate this integrand here, x to the 4th minus 3x cubed, from minus 2 to 2. First question we should ask is this, well, we do have, do we have a symmetric interval? And we do. Minus 2 to 2 is a symmetric interval. The next question we should ask is the function x to the 4th minus 3x cubed odd or even? And the answer, it's neither, okay? It's neither odd nor even. Functions don't have to be either odd or even. One function can be both odd and even. 0, for example, is odd and even. It could be both of those. But in general, functions are neither odd or even. It's a small subset, actually, that are either even or odd. Nevertheless, we can break this integral up into 2 different integrals, okay? Using the property of integrals. And now, when we break up that original integral, we do have symmetric integration over either an odd or even function. X to the 4th is even, x cubed is odd. And using that theorem, since we're integrating the odd function from minus 2 to 2, a symmetric interval, that's just 0. And instead of integrating x to the 4th from minus 2 to 2, we could just integrate from 0 to 2 and multiply by 2. Okay, we do that, it makes our lives a little easier with the even function because inputting the bound of 0 is pretty easy on that polynomial. And you get that final answer. Let's look at another example. Here, again, we have a symmetric interval, so we could look into using the theorem above with integrations of odd or even functions. And again, the integrand is neither odd nor even, but we break it up. Cosine x is an even function, okay? Cosine x is symmetric about the y-axis, if you could imagine it. Now, what about sine cubed x? Well, sine of x is an odd function. What about sine cubed of x? Well, here, rather than, mental gymnastics, let's actually just go ahead and calculate it. If f of x is equal to sine cubed x, well then f of negative x is equal to sine of negative x cubed is equal to sine of negative x is negative sine of x. Again, sine of x is an odd function. And this will give us negative 1 cubed sine cubed x. Well, negative 1 cubed is just negative 1. So we'll get negative sine cubed of x, and that means that we get negative. And that's exactly the definition of an odd function. Okay? And so this is odd. And rather than integrating that, which, we would have to use our tricks with trigonometric substitution and break up that power and then use the half angle formulas. Well, no, it's just 0. We just saved ourselves 10 to 20 minutes right there. Okay? And you then integrate that cosine x using the property that you could just multiply by 2 from 0 to pi over 2. Okay, it's a symmetric about the y-axis, and you get this result. So much quicker thanks to using the theorem for integrating odd or even functions.